Alright, before we start, I just want to make something very clear. I'm not a math teacher, I'm a student of grade 9 who is going to give his O level or GCSE exams next year or the year after that. I'm just a student who wants to help other students by teaching them what I already know. I'm not a professional, so if there's any problems, if you have any complaints or criticisms, just comment them. Okay, anyway, let's start. So the topic of this video is quadratic functions and equalities. So first of all, before we start talking about the quadratic functions part, let's go over inequalities. What are inequalities? So normally equation has three things: left hand side, equal sign in the middle, and the right hand side. So the equal sign is there to represent the fact that the left hand side, let's for example write 2 plus 1, left hand side is equal to, which is represented by the equal sign, 3. That's why it's called an equation, because it's equal. But imagine something like 2 plus 1 is less than 4. This is not an equation. It's a sort of equation, but it's actually an inequality because the left hand side and right hand side are not equal. And that's what we're going to be discussing today. Before we start, I just want to go over the basics. This is the less than sign, this is the greater than sign, this is the less than or equal to sign, and this is the greater than or equal to sign. Okay, now that we have done that, let's just before we start on the quadratic functions part, one last thing. So imagine something like 2 is greater than 1. Okay, simple enough. If you multiply both sides with like 2, it becomes 4 greater than 2. So imagine multiplying them with a negative number like minus 1. You would expect the sign to be the same, and this would be minus 4 and minus 2. That's how most people would think when they're first learning inequalities. They would just write the answer without checking it. But this is actually incorrect, because when they're multiplied by the negative number, their values completely change and they become opposites, and the sign itself needs to change because negative 4 is less than minus 2, so the sign needs to change. Now that we have that out of the way, let's get started on the quadratic functions part. Okay, so in order to understand quadratic functions and equalities when they go together, we got to understand what exactly quadratic functions are. They're functions of where the highest power of x is 2. For example, f of x equals to x squared, which is the same as y equals to x squared. We just write it as f of x because the function, it represents the process of turning x into the value of y. So if we input a value of x within the brackets, imagine 1, then we would get an output which is the value of y. That's what a function is. And we need to understand the graph for quadratic functions in order to understand what happens when quadratic function and inequalities go together. So first of all, let's try a value for x over here. So let's input x as 1. So x squared is equal to 1 square, so y is equal to 1. And on the graph, that point would be over here. Over here, let's just imagine that y is 1 over here and x is 1 over here. Let's try minus 1 as well. So if x is minus 1, then y is actually positive 1. So it would be right here. Y is positive 1 in this part, but x is negative 1. So minus 1 whole squared is positive 1, so it would be right here. Okay, let's do 0. Let's try 0. 0 square would be 0 square, so it would be right here. Some of you may be starting to understand what I'm trying to do here. Okay, so let's try 2 for x. So 2, so 2 square is 4. So over here we'll write 4. So we're just trying to plot the values of x and y onto the graph to show you the line that is formed when we have a quadratic function. So over here it would probably be around here. Let's try minus 2, and when the value of x is minus or positive, it doesn't matter because y will be positive either way. Always remember, a negative squared is positive, so minus 2 whole squared is the same as 2 squared, so it becomes 4. So it would be around here as well. So let's try minus 3. Minus 3 whole squared is 9. So over here it would be somewhere around here. Okay, let's try just positive 3 for x. So 3 squared is 9. So over here it will be like this. Okay, so can you see the curve that's starting to form over here? Like if you follow the line, then it would be like a smiley face. That's what the line of a quadratic function looks like. It's a curve. Okay, so now you know why the line goes upwards like a smiley face when f of x equals to x squared. Even when the value of x is negative. It's because negative squared is still just positive. That's why it's like a smiley face. But what happens if it's negative x squared? What happens if y is equal to negative x squared or the function is equal to negative x squared? Well, let's see what happens. Let's start with 1. 1 squared is 1. Minus times 1 is minus 1. So 1 of x is over here. And negative 1 of y is not up, but it's down. So it's somewhere around here. It's around here somewhere. Okay, let's try negative 1 squared is just 1, positive 1. And positive 1 times minus is minus 1. Okay, so it's around here somewhere because negative 1 for x is over here and negative 1 for y is over here, so it's somewhere around here. Okay, so now let's try minus 2. Minus 2 squared is positive 4 and positive 4 times minus is minus 4, so it becomes negative 4. So minus 2 for x is right over here somewhere, and for y minus 4 is right over here somewhere. It would be right over here somewhere. Okay, now let's try positive 2. So now let's try 2. So 2 squared is 4 and 4 times minus is minus 4. So minus 4. So minus 4 will be right here. So as you can see, unlike the graph for the positive x squared, for the function of positive x squared, this one is going down. It's like a sad face. This is very important. So as you can see, it goes downwards like a sad face. So here's how you can remember what the line looks like for the different functions of x. When it's negative x, it's sad because it's negative. Negative means sad. You can think of it like that. And when it's positive, it's a smiley face because is positive means happy. So it's a smile. That's how I remember it. So let's start off with an example. X minus 2 times x minus 3 is greater than 0. How would you do this? Forget everything about inequalities. Treat this as x minus 2 times x minus 3 equals to 0. So if you factored it, if you divide both sides with x minus 3, you would be left with x minus 2 equals to 0. Just ignore the greater than sign. So x would be equal to positive 2. Here's the positive 2. If it was a normal quadratic equation, the ones that you are probably used to. And if we divide both sides with x minus 2, then we'd be left with x minus 3 equals to 0. And move the 3 over to the other side, so x would be equal to 3. So 2 and 3. Remember those. So now that you have these values of x, if it was a proper quadratic equation, what do you do with them? Well, these values represent the points at which the line or the curve intersects with the x-axis. So this point is 2 for x and this point is 3. And by the way, the reason why it's the intersection point of x-axis is because it's equal to 0. Remember, a function of x is equal to the value of y. So x minus 2 times x minus 3 equaling to 0 means that y is 0. And where is y 0? Straight at the x-axis. So that's why when it's 2 at the x-axis and it's intersecting the x-axis, y is 0, and over here the same, y is 0. Okay, now that we have that out of the way, now that you understand that part, what to do next? How do you get the ranges of values of x? Well, over here it says greater than 0. So we know that x minus 2 into x minus 3 is a value greater than 0, a positive number. So it could be 1 or 2 or 3, but it can't be minus 1. So how do you get a positive number by multiplying? It can be minus into minus, which is equal to positive, or it can be positive into positive, which is equal to positive. Okay, remember that. So x minus 2 and x minus 3 can either be both negative or they can both be positive. Remember that. So now let me just get rid of this. So x minus 2 and x minus 3 greater than 0, meaning that they're positive. So in order for so imagine that they're both positive. X minus 2 and x minus 3 both are greater than 0. So in this case, let's divide both sides with x minus 3. So it would be x minus 2 is greater than 0. So x would be greater than 2. And if we divided both sides with x minus 3 when we're considering them positive, if we're dividing both sides with x minus 2, then it would be x minus 3 greater than 0, which we can simplify to x is greater than 3. Okay, x greater than 3. Okay, now that we have these two ranges of x, remember, when a question like this comes, they will most likely ask you the range for values of x, not the exact value, because there's normally an infinite amount of values for x. There is actually an infinite amount of values. So you got x is greater than 2 and x is greater than 3. So at this point is the value of 2 for x, and at this point is the value of 3, and the values of x can both greater than these. So you should take the greater value, which is 3. So you take the greater value for 3. So x is greater than the greatest when it's greater than 0. Okay, now let's take both of these as negative. So it becomes x minus 2 is less than 0 because it's negative, and x minus 3 is less than 0. So if we simplify both of these, we get x is less than 2 and x is less than 3. So when you get the less than values for x, you will want to take the lowest value. So you'll just ignore this part and you'll just take this as the value of x, as the range of x for lowest. So x will be on this side. You don't count the middle part. You don't count this part for x is less than 3. You just go from the 2. X is less than 2. And the same thing for x is greater than 2 and 3. You take the greatest when it's greater and you take the smallest when it's smallest. So x is smaller than the smallest, which is 2, and x is greater than the greatest, which is 3. And if your sir asks you to show the graph and show the ranges of x using the graph, this is how you'll draw it. Okay, so now you know how to do it. So you know the ranges of x. Now how will you show them? Here's how you'll show them. You'll just write x is smaller than the smallest, which is 2. So x is smaller than 2, and then write and x is greater than 3. So that's how you would show the ranges, and that's your answer. Normally you would actually not get this simplified factorized version. You would get something like x squared minus x plus 5 or something like that, and you would have to factor it yourself. Okay, now that we have done greater than, let's do less than. Okay, here I have another example. It's basically the same thing, but we use less than sign. X minus 2 times x minus 3 is less than 0. So how would you do this? Well, you would start off the same way. You would divide both sides by each term and you would get x equals to 2 or 3 if it was a normal quadratic equation where it was equal to 0, not less than. Okay, now you would write it on a graph if your sir asks you to show the graph for it. So 2 will be over here and 3 will be over here because 2 is less than 3, and the lower value of x is on the left side because x is lower on the left side. So how do you do the rest of it now? Well, x minus 2 times x minus 3 over here is written as less than 0, meaning that it's minus. It's a negative value. And how do you get negative value by multiplying? Well, you can either do minus into plus, which is equal to minus, or you can do plus into minus, which is equal to minus. Okay, so now we just got it for x minus 2 and x minus 3. We gotta take x minus 2 as both less than and greater than, and then we're gonna do the same for x minus 3. Okay, now let's do it. X minus 2 is greater than 0, while x minus 3 is less than 0. So over here x is greater than 2, and over here x is less than 3. Okay, now let's do the opposite. X minus 2 as negative. X minus 2 is less than 0, and x minus 3 is greater than 0. By the way, you don't have to show all of this. I'm just showing all of this to make you understand. So x is less than 2, and over here x is greater than 3. Now what you're gonna wanna do is find the values for x in between this, because over here the values of x dip below x-axis, meaning that the values of y are negative here. And remember, this function over here, x minus 2 times x minus 3, it represents the value of y. What happens to y if you change the value of x? Meaning that if it's less than 0, then that means the value of y is less than 0, meaning that y needs to be negative, and y is negative below the x-axis over here. So that means we need the value of y that is in between 2 and 3, meaning that x needs to be greater than 2 and x needs to be less than 3. So we'll take this part and we're gonna take this part. So simply we're gonna write our answer as 2 less than x, which is less than 3, in order to get the value of x that is in between 2 and 3, so that we can get a value of y that is less than 0, because over here x minus 2 times x minus 3 is less than 0, meaning that it's negative, and this is equal to y, because remember, function of x is always equal to y. So y is less than 0, so it's negative, meaning that it's below the x-axis over here. And in order to be below the x-axis, it needs to be between the values of 2 and 3 for this question, and you just write your answer as this. By the way, you don't have to show all of that x minus 2 greater than 0, x minus 2 less than 0, taking each as negative and positive. That was me just showing you to make you understand. Okay, one last thing before we finish this class. What if instead of just being less than 0, it was less than or equal to 0? The only difference that there would be is that you would put less than or equal to and less than or equal to, and it would be the same for if it was greater than or equal to. You just write greater than or equal to the greatest, or less than or equal to the least. I'm gonna repeat one last time. You don't have to show all of that about x, taking each term as negative and positive and then simplifying in order to get the ranges. You just gotta write this part. And if it's not already factored, then you gotta middle term factorize it and then get the values of x. That's all for today. If you have any questions, any problems with the video, or any complaints or criticisms, please comment them down below. This is my first video. I'm trying to improve and I just want to help others. I'm just a student, so please don't be hard on me. Anyway, that's all for today. Goodbye.